Greetings! This is Unit 6, Module 3, Session 1. The name of this home connection is Rope Climb Results and Skills Review. It's good to get a review in just in case. And why not climb some rope while we're at it? Because our PE teacher is challenging us to a class rope climb. And there are 8 blue pieces of tape equally spaced and wrapped around the rope to mark off the distances. The following results represent the goal levels that were reached by the students in your group. So picture in your mind a rope hanging from the ceiling, and every here and there, evenly spaced, are these blue pieces of tape, and your goal is to get as high as you can, get to the highest blue tape. Some people can get pretty high, some people can go some distance, but it looks like there's a lot of individuality here, okay? And this would be a good example. Is like, so some people maybe got 1/8, and then some people got 2/8 and 3/8, so you climb as high as you can go and see if you can reach your goal. Now it says display this data on the line plot below. So I have 1/8 over here, I have 8/8 over here. Looks like we're counting by eighths, and then how many do I have in the middle here? I have 1, 2, 3, 4, 5, 6 that are left. How am I going to fill out the rest of this line plot? So it looks like I'm going from 1/8 to 8/8. Does it work if I just keep going in number order? 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So it does look like I can just keep going 1/8 at a time, and I suggest we at least start with that. 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. We need to give this a title. What do you think would be a good one? So maybe rope climb. How about something simple like that? Okay. We're going to display, these are the numbers that the students received. So it looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students in the class, and this is how high they all went. So I need to place an X on my line, on my plot, for every distance that was achieved. So one student went 4/8. Now we can get rid of that number. One student went 1/8. Another student went 3/8. Okay, look, another student matched another student, and that's okay. We just put another X in that spot. Okay, we have 4/8 again, 2/8 here, and you can pause this video and do it if you'd like to. 3/8 here. I'm just going through the list and then marking the ones that the class got. Another 4/8. Okay, we've got 1 6/8, and then it looks like 1 7/8. Notice no student made it to 5/8. I'm still going to leave that there because the PE teacher had to have taped it. There's just no one got to it. Either people went lower or higher, and that's totally fine. Okay, 3 students though did 4/8. It says, how many students stopped at the goal line 3/8? So how many students got up to 3/8 and then had to stop? Looks like 2. Which goal level did the most students reach? Well, which one has the most X's? 4/8. How many students touched or even passed 3/8 of the rope? Touched or passed? 2 touched it, but 1, 2, 3, 4, 5, 6 passed it. So I'm going to add those 6 plus the 2 that touched it. So that would be 8. And what was the total distance combined for climbing the rope? That means I'm going to have to take all 11 scores and add them together. And you could, if you wanted to, just do that up here. I know that I'm going to leave the denominator the same, right? Because I can add 4/8 plus 1/8 and get 5/8. The top number is going to change, the bottom number will not. So I'm going to add 4 plus 1 plus 3 plus 1 plus 4, 2, 3, 8, 4, 6, and 7. And then I'll have an answer over here that still is in eighths on the bottom. Okay, do not change the denominator. Let's only add the top numbers. So 4 plus 1 is 5, 8, 9, 13, 15, 18, 26, 30, 36, 43. I gotta double check this. Okay, just making sure I added my 7 on right. Normally I would do it on paper, but to save time I was doing it in my head. 43 eighths, okay, and I can bring that down here. 43 eighths, and are we in inches? I'm just reading through the paper, and I do not know if I see I don't see any units. So 43 eighths, maybe we'll just say inches just because. Now, what if I want this to be a mixed number? Right now it's an improper fraction. Okay? So in order to do that, I know that I'm going to have something and something eighths, right? I'm going to have a whole number and then whatever's remaining, if there is something remaining, right? How many eighths fit into 43? Because technically this is a division problem, 43 divided by 8. How many eighths fit into 43? Well, if you did a ratio table, we could do that real quick. 1 is 8, 16, 24, 32, 40, 48. Well, 6 is too many because we don't want 48 because that's too much. How many do fit? 5. Okay. So if 5 will get us to 40, how many is left over to get to 43? 3. So the answer would be 5 3/8 inches. Solve, oh my goodness, table or an array model. Oh gosh. Let's do both. And I know you're probably thinking, please don't, no, don't do it. So, and we can do this maybe. I don't know how many rows I'm going to need, so I'm just going to add a whole bunch, just in case. I don't think we'll need that many, but we know 1 times 6 is 6. We know that 10 times 6 is 60. Okay, just to make sure we don't need a bigger number, let's say 2 times 6 is 12. So 20 times 6, add a 0, 120. 3 times 6 is 18, which means 30 times 6 is 180. And then 4 times 6 is 24, which means 40 times 6 is 240. Too big. So we know 40 is not an option. Okay, we're trying to get to 216. Okay, so how am I going to do that? 30 is a good place to start. Okay, we know that we can't add 10 more, so it's going to have to be less than that. Is 5 an option? I only say that because 5 is half of 10. Half of 60 is 30. So what if I take 120, or actually 180, and I add 30? That's 210, right? Because 180 plus this 30, if I just add it, is 210. Wow, I'm only 6 away. Well, I know I'm going to use my highlighter because it just helps my brain think. I'm trying to get to 216. So far, 180 and 30 get me to 210. If I just add another 6, I'll be at 216, and that's what I want. And I could write this down. 210 plus 6 is 216. Okay. So if these 3 numbers equals 216, then the numbers on the left are how many 6s I need. So that would be 30 and 5 and 1, which is 36. So if I divide 216 by 6, I get 36. Now, if I use the area model, it's going to look very similar. And I tend to make a rectangle that's way too long. And if you don't need all of it, that's fine. But we know we're counting by 6s. Okay? And the same thing is true. Like if I were to take 6 times 30, I would get 180. Because this is our area model, right? 6 times 30 is 180. And then if I did 5 more, 6 times 5 is 30. And then if I did one more 6, and that could have probably been skinnier, but that's okay. 6 times 1 is 6. And if I were to add all of these areas, 180, 30, and 6, that would give me a total area of 216. Once you have the 216 that we were starting with, then all I need to do is add the numbers up top, which are the multiples of 6 that I used, right? I used 30 times 6, 5 times 6, 1 times 6. 30 plus 5 plus 1 is 36, which is the answer that we got on the first side. And if you still weren't satisfied, we could technically maybe just sneak in, double check our answer, do a little bit of long division. How many 6's fit in 2? None. How many 6's fit in 21? 3, because 3 times 6 is 18. Subtract these two numbers, you get a 3. Bring down your 6. How many 6's fit in 36? Exactly 6. There's the answer again. So we can double check our answer a few different ways and feel very comfortable about it, okay? Kevin says that 0.6 is the same as 6/10. Do you agree or disagree? Well, how do you pronounce this decimal? Okay, this is the ones place here. Here is the tenths place here. No number here, so I have 6/10. So just to pronounce this number, I am going to say 6/10. So I'm going to agree with Kevin, because 6, the place value after the decimal is tenths, and there are 6 of them. Write each fraction as a decimal. They did the first one for you. These two are going to be very similar. I'm going to do this one here, only because it's a little challenging. There's no whole number, right? None of these have a whole number in front of them, so we know that it's going to be 0 point something on every single one of these, because it doesn't say 1 in 300ths, it says 300ths. Now if I write 0.3, I have written 3/10, so that is incorrect. What I'm going to want is 0.03, because this is the hundredths place. This is the tenths. Okay? 300ths, the 3 needs to be in the hundredths place value. Okay? And then it ends up being 300ths. Okay? Writing each decimal as a fraction. These two here are going to relate to your top row. These two are going to relate to your bottom row, because I'm working with tenths here. I'm working with hundredths here. I know that because there's only one place value after the decimal, but here there are 2 digits after the decimal. Okay? Greater than, less than, equal. Remember, the alligator eats the larger number. If you have denominators that do not agree, and logically you can't quite figure out what's going on, there's a couple things you can do. I can make the bottom numbers agree by figuring out what the least common multiple is of these numbers. And how does that work? Well, 3 times 2 is 6. Well, I can't turn 4 into 6. 3 times 3 is 9. I can't turn 4 into 9. 3 times 4 is 12. That does work. I could take this whole thing times 4, and I would get 3 times 4 on the bottom, which is 12. 2 times 4 on the top, which is 8. And I can turn this 4 into a 12 by taking it times 3, right? And so I can take, and this is not the proper way you would write this, by the way. I'm just showing here that you're going to quadruple both numbers, and here you're going to triple both numbers, okay? 4 times 3 is 12, and then 3 times 3 is 9. So now my bottom numbers do match. I have 12s and 12s. I have 8 and 9. The alligator eats the larger number. There is another way you can do a problem like this, which is by saying 2/3 is all but one piece. 3/4 is all but one piece, right? Because it's 3 out of the 4, and this is 2 out of the 3. So when we're talking about thirds, I have all the thirds except 1 on this side. And when we're talking about fourths, I have all the fourths except for that one. So if you are thinking about it as maybe a what's left over problem, then this matters quite a bit, because let's say I talk about thirds, which is something like this, and then I'm talking about fourths over here. Which pieces are larger? Well, the thirds have larger pieces. Well, if I have 2 of the 3, that's all but 1. Okay, 2/3 is everything except 1. 3/4, we said they're smaller pieces, but we have all but 1. So I have 1, I have 2, I have 3/4. That's what this says here. Well, if you talk about one whole thing and you take a smaller piece away, there's more remaining here. Because if I have everything except one piece and I take away this larger piece, I have less left over. So sometimes you can think about it as what is remaining. And so if I have all but 1 and all but 1, but on this side I take a smaller piece away, yeah, this is bigger. Okay, because there's more left. Okay, when you do these remaining, don't forget your zeros rule here. That's going to be helpful. This is going to be a nice one because you'll be able to turn 3 into 9, which will help, which you actually don't have to do because you have a 1 on the top. You just need to figure out which pieces are bigger. Is a third bigger or is a 9th bigger? And you could even think about drawing it. Cut something into 9 pieces, cut something into 3 pieces. Which one has bigger pieces? That will be your answer, okay? Okay, we covered that one. These two here, we can make these maybe just a little bit more agreeable by, you'll probably double this side here. And you can make this side agreeable by taking this times 5. Okay, so giving you some little hints there, just to make them easier to process. Okay, I know that's a little bit of a longer video, but there are so many great things in here. It's a skills review, so we're trying to review several units worth of material. Not everything that we've learned, but quite a bit. If you have questions, make sure you ask. Teachers love to help. Check you later.